Hello, in this video I'm going to give a brief overview of chemistry and looking at how that's important for human biology. So in order to talk about chemistry, we really have to talk about atoms. Atoms are the basic structures that make up matter, right? Matter is anything that has mass and occupies space. So that includes things like air and our desks and our bodies. So atoms themselves are composed of smaller pieces called subatomic particles. That's a big fancy word to talk about things you probably already know. These are protons, neutrons, and electrons. So an atom is composed of protons, neutrons, and electrons. An atom has a nucleus, or a center region, where we're going to find protons and neutrons, and then outside of the nucleus is where we find the electrons. Protons have a positive charge, neutrons, as the name suggests, have no charge, and electrons carry a negative charge. So here on the screen we can see a model of a helium atom, right? In the nucleus we can see 2 neutrons shown in yellow, 2 protons shown in red, and then outside the nucleus we can see 2 electrons shown in gray. So this is a pretty typical model for an atom. Atoms that have the same number of protons have the same basic properties and they belong to the same element. You're probably familiar with the periodic table of elements. Elements include things like helium, oxygen, carbon, nitrogen, gold, right? So protons determine the atomic number for a particular element, right? It just so happens that carbon is atomic number 6 because it has 6 protons. Right? Oxygen has the atomic number 8 because it has 8 protons. Something else you can find on the periodic table of elements is something called the atomic mass, as in weight. So each atom has a weight to it, and this is composed of basically the weight of the protons and the neutrons. So the atomic mass is determined by really the weight of the protons and neutrons. And ultimately the weight of the protons and neutrons is due to their quantity. So if you have 2 protons and 2 neutrons, then the atomic mass would be 4. So you just add up the numbers of protons and neutrons to determine the atomic mass. Electrons really don't have any mass, so they don't contribute to the atomic mass of an element. So let's look at some different pictures. Right? So here we see a hydrogen atom, our helium atom again in the center, and then a lithium atom. Right? Looking at the hydrogen atom, this one's a little bit different because it doesn't contain any neutrons. It has 1 proton in the nucleus and then 1 electron outside the nucleus. Let's look at lithium now. So lithium has, in this case, 3 protons in its nucleus, 4 neutrons in the nucleus, and then 3 electrons outside the nucleus. So this is a good example that shows you that the number of protons and the number of neutrons don't have to equal each other. Sometimes they do, like we see in the example with helium here, but sometimes they don't, like we see in the examples of hydrogen and lithium. Next, I want to talk about isotopes. Isotopes are different versions of the same atom, and what's different about them is their number of neutrons. So here we actually see 3 different types of hydrogen. They're all hydrogen because they all have 1 proton in the nucleus, and if you have 1 proton in your nucleus, then you have to be hydrogen. But each of these 3 examples differs in their numbers of neutrons. So these are 3 different isotopes of hydrogen. Now, isotopes are really important in human anatomy and physiology, mostly because isotopes can be used in medicine. We use radioactive isotopes all the time in medicine as tools to create images of the body and body parts, but radioactive isotopes can also be used as a treatment for things like cancer. So isotopes are important in human anatomy and physiology. Somewhat related is the topic of ions, right? So just to review, isotopes were different versions of the same element that had differing numbers of neutrons. Ions, however, are charged atoms or molecules. The term molecule, by the way, just means a group of atoms. So an ion is something that carries charge. Isotopes don't necessarily carry charge. Ions do carry charge. So in the picture here, we can see both a sodium ion and a chloride ion. The sodium ion is carrying positive charge, and the chloride ion is carrying negative charge. And the reason why these particular atoms are charged is because their numbers of electrons and protons are not equal. The sodium ion here has one more proton than electron, and the chloride ion has one more electron than proton. So they became charged. We can use the words cation and anion to describe whether an ion has a positive charge or a negative charge. So there's a T in cation, and the T looks a lot like a positive sign. Cations are positively charged ions. Right? Another way to remember this is that the cation is positive, like cats have paws. Right? The anion then refers to a negatively charged ion. Okay? Notice here in this picture that the sodium ion and the chloride ion are hanging out by each other. They have formed a molecule. So as I said before, a molecule is a group of atoms that are held together in a stable association. So the sodium ion and the chloride ion are hanging out with each other, and in this case they're hanging out with each other because the positive attracted to the negative. So this group, the sodium ion and the chloride ion group, this molecule is what we would see like in table salt. This is sodium chloride, which is the main component to table salt.